Hello friends, welcome to this module Basic Concepts 3. In this module, we are going to discuss two important concepts, moment of force and moment of couple. Before discussing these concepts, let us recall the concepts that we have studied in the previous module. Force and characteristics of force. What is force? Force is defined as an external agent which tends to change the state of rest or motion of the body. Simply, it is a pull or push that results from an interaction between the two bodies. To define or to describe the force completely, we must know its four characteristics: magnitude, direction, point of application, and sense. Right? Types of force systems. What is force system? When two or more forces are acting on a body, then the group or collection of those forces is known as a force system. In engineering, there are four basic types of force systems: coplanar and a non-coplanar force system, concurrent and a non-concurrent force system, parallel and a non-parallel force system, and collinear and a non-collinear force system. Then there is a combination of these systems like coplanar concurrent, coplanar non-concurrent, non-coplanar concurrent, non-coplanar parallel, and so on. In today's module, we are going to discuss the learning outcomes of this particular module, then moment of force, couple, the difference between moment of force and moment of couple. Then we are going to summarize these concepts followed by a quiz with answers. After completion of this module, you shall be able to define what is moment of force and a couple. You are also in a position to differentiate clearly between the moment of force and a moment of couple. Moment of force. What is the effect of force on the body? The effect of force on the body is twofold: to produce translation and to produce rotation. So let us consider a body which is kept on the horizontal surface. Say G is the center of gravity of the body. Now, if a force is applied on the body in such a way that the line of action of the force is passing through point G. Now, what is the effect of this force on the body? To produce translation. Means the position of G is changing from one point to another. The moment there is a change in the position of the center of gravity, we can say that the body is having translation. So here the effect of force on the body is to produce translation. Suppose, let us assume that this body is fixed to the horizontal surface at the center of gravity. So G is fixed. Now force is applied at the corner. Now what is the effect of this force on the body? It tends to rotate the body about G. Right? The position of G is not changing. Hence, body is not having translation. But the body is rotating about G. So the body is having only rotation. Suppose if this body is simply kept on the surface, it is not fixed. Please note this point. Body is not fixed to the surface. Simply it is kept on the surface. Force is applied at the corner. Now what is the effect of the force on the body? The force tends to move as well as rotate the body. So the position of G is changing. Hence body is having translation. At the same time, the body is rotating about some arbitrary point. So it is also having rotation. Right? So here the effect of force on the body is to produce translation as well as rotation. This rotational effect or turning effect produced by the force on the body is known as a moment of force. Right? The moment of force about a point, it is calculated by taking the product of the magnitude of force and the perpendicular distance from the line of action of the force to the point about which the moment is to be taken. So moment is equal to force into distance, perpendicular distance. Sense of the moment is either clockwise or anti-clockwise, depending on whether the force tends to rotate the body in clockwise direction or anti-clockwise direction. In our study, anti-clockwise moments are taken as positive and clockwise moments are taken as negative. SI unit is Newton meter. Simply it is force into distance. Now consider a rod AB of length 2 meters. Let a force of 50 Newton is acting at point B at an angle of 45 degrees with respect to horizontal. Now to find out the moment of this force about point A. So moment of force about a point is equal to force into distance. Which distance? Perpendicular distance from the line of action of the force to the point. Here, what is the sense of the moment created by this force about A? So this force tends to rotate the body in clockwise direction. Hence, the sense of the moment of this force is clockwise. Now, D is the perpendicular distance from the line of action of the force to point A. So, from geometry, we have this angle 45 degrees, and from the right angled triangle ABC, sine 45 is opposite side D upon hypotenuse 2. So, D is equal to 2 sine 45. Therefore, moment about point A is minus force is 50 into distance 2 sine 45. Minus because sense is clockwise. That gives you minus 70.71 Newton meter. So, it is 70.71 Newton meter clockwise. Understood? The point about which the moment is taken, here point A, is known as moment center. And the perpendicular distance D is known as moment arm. The moment of force about a point is 0 if the line of action of the force is passing through that point. Means if the force is acting at that point and you want to take moment about that point, its moment will be 0. Being the line of action is passing through the point, the perpendicular distance becomes 0. Hence, the moment of the force about that point is 0. Now let us consider one numerical example. Determine the moment of force P acting at point C shown in figure about point A and point B. Now here we have to calculate the moment of force P about point A and about point B. Now say the direction of this force with respect to horizontal is alpha. From the right angle triangle ABC, we have tan alpha is equal to opposite side by adjacent side. This gives you 36.87. Now, first we will calculate moment of this force about A. So, if you see this figure, the line of action of this force is passing through point A. Means the perpendicular distance from the line of action of this force about point A will be 0, right? Therefore, the moment of force P about point A is 0, since line of action of force P is passing through point A. So perpendicular distance D is equal to 0. Therefore, its moment about point A is 0. Now, to calculate moment of this force P about point B. Now, what is the sense of the moment created by this force about B? So, it is anti-clockwise. So, we'll consider anti-clockwise moments as positive. So, it is the product of force perpendicular distance. Force is 30 Newton and perpendicular distance from the line of action of the force. So, D is the perpendicular distance. Let us say this is capital D. From the right angled triangle BDC, we have sine alpha is equal to opposite side by hypotenuse. So D is equal to 4 sine alpha. Therefore, the moment about point B is magnitude of force is 30 into D, that is 4 sine alpha. Alpha is 36.87. So that gives you 72 Newton meter. So it is anti-clockwise. So the moment of force P about B is 72 Newton meter. Okay. Now couple. Couple means pair. Pair of two forces. If two equal and opposite parallel forces are acting on a body, then they are said to form a couple. Consider this body on which two forces of magnitude F are acting at the points A and B, and they are parallel to each other, acting in the opposite direction. So the distance between them is, say, D. Now these two forces are said to form a couple on this body. What is the effect of the couple on the body? To produce rotation. So the effect of couple on the body is to produce rotation. This rotational effect produced by the couple on the body is known as moment of couple. Moment of couple is calculated by taking the product of the magnitude of any one of the force and the perpendicular distance between the lines of action of these two forces. So M is equal to F into D. Like moment of force, moment of couple can also be a clockwise or anti-clockwise sense, depending on whether the couple is rotating the body in clockwise direction or anti-clockwise direction. So in our study, anti-clockwise couples are taken as positive and clockwise couples are taken as negative. The SI unit is, again, here it is Newton meter, force into distance. Okay. Suppose if you want to turn the steering wheel in clockwise direction, then accordingly you have to apply a couple which tends to rotate the wheel in clockwise direction. Right? We are applying the couple to turn the wheel in clockwise direction. Now characteristics of couple. So these are very important. Couple does not produce translation but tends to rotate the body. Why it is so? This is because the resultant force of the couple is 0 in any direction. as the resultant force is 0, it is not having translation. Couple cannot produce translation. But the resultant moment of the couple is not 0. Therefore, there will be a rotation. Okay. Now see this example. Two forces of magnitude 10 Newton. They are acting at points A and B parallelly in the opposite direction at a distance 2 meters. So these two forces are forming a couple on this body. To determine the resultant force, let us consider this positive x and y axis. Resultant force is nothing but the algebraic sum of the forces, right? So here the forces acting downwards will be considered as negative, upwards positive. Accordingly, here the two forces are acting in y direction. Therefore, algebraic sum of these two forces in y direction is 0. So the resultant force is 0. Therefore, no translation. Now, if you calculate the resultant moment about any point, let us say about point A, then resultant moment is the algebraic sum of the moments of these two forces. So the moment of 10 Newton which is acting at point A is 0 because the line of action is passing through A, and the moment of 10 Newton which is acting at B about point A is 10 into perpendicular distance 2, that is 20 Newton meter, and the sense is anti-clockwise. So the moment of this couple is 20 Newton meter anti-clockwise. It is not 0. Therefore, the couple will tend to rotate the body. Moment of the couple is always constant. It is independent of the point about which the moments are taken. Now consider the same example. Here the moment of couple is force into perpendicular distance between the two forces, that is 10 into 2, 20 Newton meter. Sense is anti-clockwise. Now if you take the moment about point A, so we have seen that the resultant moment about point A is 20 Newton meter anti-clockwise. Moment of this 10 about A will be 0. Moment of other 10 Newton is 10 into 2, 20 Newton meter anti-clockwise. Now if you take moment about B, again you are going to get it as 20 Newton meter anti-clockwise. Here moment of 10 Newton force which is acting at A about B is 10 into 2, 20 Newton meter anti-clockwise. The moment of this 10 will be 0 as it is passing through point B. So again 20 Newton meter anti-clockwise. Now you consider point C at a distance 1 meter from A. Then if you calculate the resultant moment about point C, then you will find that the resultant moment is 20 Newton meter anti-clockwise. So moment of this 10 acting at A about C is 10 into 1 anti-clockwise. Similarly, the moment of this 10 which is acting at B about C is 10 into 1. So it is 20 Newton meter anti-clockwise. Even if you consider point D at a distance 3 meters from A, then if you take the resultant moment about D, you will find that it is 20 Newton meter anti-clockwise. So moment of 10 Newton which is acting at point A about D is 10 into 3, 30 Newton meter. Sense is clockwise, right? So it is minus 10 into 3. Then moment of this 10 Newton about D is 10 into perpendicular distance is 3 plus 2, 5 meters now, and sense is anti-clockwise. So it is plus 10 into 5. That results in 20 Newton meter anti-clockwise. Means if you take the resultant moment of the couple about any point in the plane, it remains constant, right? So it is independent of the point about which the moments are taken. Then two couples are said to be equivalent if they have same magnitude and sense, irrespective of the forces constituting the couple. So here there are two couples formed by two 10 Newton forces and two 5 Newton forces, right? These two are different couples. What is the magnitude of the first couple? It is 10 into 2, 20 Newton meter. And what is the sense? So this couple tends to rotate the body in anti-clockwise direction. Similarly, what is the magnitude of moment of the other couple? So it is 5 into 4, 20 Newton meter. Again, the sense of rotation is anti-clockwise. So here both the couples are having same magnitude and sense. Then you can say that these two couples are equivalent, irrespective of the forces constituting the couple. So here on left hand side, the couple is formed by two 10 Newton forces. On right hand side, couple is formed by two 5 Newton forces. But the effect of those two couples in magnitude as well as sense is same. Therefore, those two are equivalent. Okay. Now let us see the difference between the moment of force and moment of couple. Moment of force is the turning or rotational effect produced by the force on the body. Moment of couple is the rotational effect produced by the couple on the body. Moment of force is calculated by taking the product of the magnitude of force and the perpendicular distance from the line of action of the force to the point. And the moment of the couple is calculated by taking the product of the magnitude of any one of the force and the perpendicular distance between the two lines of action of the forces constituting the couple. For a given force, the moment depends on the point about which the moment is to be taken. If the position of the point is changing, the perpendicular distance will change. Therefore, the magnitude of the moment of force will change. Whereas, for a given couple, the moment is independent of the point about which the moment is to be taken. Right? So you take any point in the plane, but the moment of that couple remains constant. This is the basic difference between the moment of force and moment of couple. So in this module, we have discussed in detail about the two concepts: moment of force and moment of couple. Moment of force is the turning or rotational effect produced by the force on the body. Here couple, it is formed by two equal and opposite parallel forces. The rotational effect produced by the couple is known as moment of couple. Moment of force is calculated by taking the product of magnitude of force and the perpendicular distance from the line of action of the force to the point about which the moment is to be taken. Whereas moment of couple, it is calculated by taking the product of the magnitude of any one of the force and the perpendicular distance between the two lines of action of the forces. Also, we have seen the basic difference between the moment of force and the moment of couple. Moment of force depends on the point about which the moment is to be taken. Whereas moment of couple, it is independent of the point about which the moments are taken. Right? Now, there will be a quiz having 8 questions. Once you see the questions, please pause the video, try to answer the questions, and you can verify your answers with the answers given at the end. Okay. So in the next module, we are going to discuss 3 more important concepts in engineering mechanics, that is a resultant of force system, equilibrium, and equilibrant. Okay. So thank you. See you in the next module.